everyone, welcome to GemChem. Now today's topic is on IUPAC nomenclature in coordination chemistry. Now before starting, already 5 videos are uploaded in channel. You can watch it. I will give the link in the description box as well as the I button present above this video. And if you are new to GemChem, do not forget to subscribe the channel. So let us start. So for IUPAC nomenclature to happen, we need a set of rules. And for that, first rule is that the name of cation should always be written first, followed by the name of anion, as we do for different salts also. Similarly, within the coordination sphere, the ligands are named first, followed by the name of the central metal ion. Third is that ligands are named sequentially in alphabetical order. Fourth is the anionic ligand are named by adding suffix O after the stem name of the ligand, and the neutral ligands are named by the name of the molecule itself with the following exceptions like methenamine, carbonyl, nitrosyl and amine. And in order to mention a number of ligands, usually suppose there are 2 ligands or 3 ligands, so we write di, tri, tetra, penta, hexa, etc. But if there is an ambiguity, the prefix are being replaced by bis, tris, tetrakis, pentakis, hexakis. And the last is that the anionic coordination entities are terminated by using ATE, while there is no such distinction for your cationic or neutral entities. So these are the rules. Now we are going to see examples in order to understand how to apply these rules. Already we have IUPAC nomenclature for organic molecules. Similarly for this one, we can see the IUPAC nomenclature for coordination compounds. So first coordination compound is CONH3 whole 4 CO3 Cl minus outside. So this is carbonate. This one is amine. So we are going to write down the name as tetra. Then we have to write down the ligand, which is amine. So we will write AMMINE, tetraamine. This is carbonate and it should be written as carbonato. So carbonato. And this is cobalt. So we will write cobalt. Try to write in one line only. Then you will write 3. That is oxidation number is +3 here. And finally give a gap and write chloride. So this all things should be placed in one line only. Now we go for our next one, where we have potassium as cation and chromium as my anion part with F5 and O as ligand. So first we are going to write down cation name, which is potassium. Then we are going to write down by giving a gap the whole anionic part. So we are writing penta fluorido, that is F comes before O. So penta fluorido, oxido, chromate, because anionic part ends with ATE. You have to write down in one line only, and the oxidation state is +3. So potassium pentafluorido, oxido, chromate 3. Next one we are going to write. So try first on your own self, then I will tell you. So for cationic part, there will be ethylene diamine. So ethylene diamine itself contains a di. So we are going to write it with regards to bis, tris, tetrakis. So here 3 ethylene diamine and we are writing it as tris in bracket ethylene diamine. In this amine we have only one M and cobalt, and here the oxidation state of cobalt is 3 and the anionic part as sulfate. Now we go for our next molecule, that is HPF6. So this one is our cationic part. So write down hydrogen, then give a blank and start writing your anionic part. So you have hexa, fluorido, phosphate. This you are going to write as phosphorus. We can't write because it should end with a 8. So we are writing phosphate, and the oxidation state of phosphorus here is 5. So this is our answer. Here we have it as fluorido. Now we go for our next example. That is, there is one anionic and one cationic part which is both complex in nature. So first we are going to see this one. So here for this part we are going to write tetrakis pyridine, tetrakis pyridine, PY stands for pyridine, we have already discussed in the previous videos, and platinum 2. Then give a space and write down tetrachlorido platinate 2. So this should be in one line only, but here you are going to give a blank space. Now the next part, again potassium is our cation and chromium is placed in anionic part. So we are going to write it as potassium. Next give a space and write tris oxalato. In the organic ligand case we are generally referring to tris bis tetrakis. And we have a chromate. Chromate comes from chromium and ATE, and here the oxidation state of chromium is +3. So we are writing here 3. So this is the full name for the second one in this page. Now we are going to see another one where there is both cationic and anionic complex part, and in this case we are going to see two different metals present, right? So here this can be written as tris phenanthroline. Phen stands for phenanthroline. We have already discussed the different ligands in the videos. So you can watch it. I will give the link in the description box as well as the I button present about this video. Now give a space and then write just after this. Since I don't have space, so I will write in the next line, but you should write in the same line. Tetrachlorido aurate 1. And in this page, the last one we are going to write it as, yes, start with potassium, then give a blank, you have chlorido, nitrido and osmium. So here we are going to write penta, chlorido, nitrido, osmate and 6, right? So this is the name. Now we go for more of the examples. So here you have sodium and here you have silver, and this is your thiosulfate. So we are going to write it as sodium, then give a space, write this will be written as bis. So we are going to write bis, thiosulfato argentate, and here oxidation state is 1 of the silver. Next one, again we have sodium and BH along with OCH3. So H is your hydride, B is your borate, that is from boron, and OCH3 is your methoxy. So we are going to write it as, first as usual sodium, give a blank space, write down hydrido trimethoxy borate 3. So you got the answer as sodium hydrido trimethoxy borate. Now this one, the next molecule is certainly a different one, where you can see that something is missing, right? So this one will be eta 5. What does this mean? We can draw the C5H5 as this one, right, which has H here, 5 of the H. And our Fe have coordinated with all these centers. There is 5 number of coordinations with the C5H5. Similarly, down portion also we have another such ring and it is coordinated like this. So this is our total molecule and we have to write down its name. So the structure looks like this. That is this one. We have iron in between, and here also we have another ring and it is joining with all the 5 bonds present. That is, there is an encircling of the pi bonds from which the bonding is occurring with Fe. Now we are going to see the name of it. So let us try first. Let me rub it off. So here we had hydrido, and now we are going to see for this one. First you are going to see how many numbers are present. So 2, you are not going to write di, you are going to write bis. So we are writing bis. Then you see there is a eta 5. So first write down eta 5. and this is cyclopentadiene. So you are going to write cyclopentadienyl, close the bracket and then write down iron. So this will be iron 2. Okay. Now we are going to shift for next such type, that is here, this one. Here it is eta 2. So you have like this a double bond and your platinum will get bonded like this. So this is your moiety. So let us start writing the name of it. Try on your own self, then I will make you write. So you have potassium at first, write down potassium. Next you will give a blank and you are going to write trichlorido. Open the bracket and write eta 2, ethene. Since C comes before E, so we have written chlorido at first. Ethene platinate 2. This should be all in one line. So potassium trichlorido eta 2 dash ethene platinate 2. Next one, see here, NCS. So we have already seen that NCS is a ambidentate ligand, right? So while writing the name also, you should clearly mention that with which center is the ambidentate ligand bonding with the metal. So in this case, we are considering nitrogen. So the name should be written as pentaamine. This is for the first part, for amino. Thiocyanato, which is NCS. But after that, you are going to mention the kappa sign followed by the nitrogen written in caps, then dash iron 3 chloride. This is the total name. Similarly, for NO2, if you see here, it can either bond like ONO or it can bond like NO2, whichever is possible. But in this case, we see here it is bonding with NO2. So its bonding center is nitrogen. So let us try to write the name similarly. So penta aqua nitrito you are going to write, then put a dash, write kappa like this, then write down capital N and then write down cobalt 3 sulfate. So this is your total answer, right? Now some more will be given to you. You are going to try out on your own self, and in the next video I will discuss the answer. Checkpoint. So try to solve these questions, and in the next video we are going to discuss the bridging ligands and how to name them. So this much for today. Thank you for watching. Do not forget to like, share, subscribe and comment.